Okay, so question one of the moments, statics, and equilibrium test. First question, a gardener used a trolley to move a paving stone. Here's the paving stone. On the trolley, there's a pivot point here. That's the first point that we need to consider, and we need to measure all our distances from this pivot point. Now, the mass of the trolley is 18.5 kilograms. So that's somewhere, because it's unevenly distributed, we're just going to pick a point where the center of mass of this trolley is, and it's somewhere along this line here. And it's not bang in the middle because there is a paving stone that's slightly offsetting the center of mass more down the actual trolley. So we've picked some point here, and that's 18.5 times 9.81, which is G. Now, when we look at moments, the force and the distance from the pivot must be perpendicular. So if this distance to the center of mass is called x, then the force that we are looking for is in this direction here, which is where x and that are 90 degrees. As we can see, 18.5 times 9.81, that's the weight. It acts vertically downwards. That's not perpendicular to this distance here. So therefore, we find this component, which is 18.5 g cos theta. Okay, because this is the angle of the incline or angle of which the trolley has been tilted, similar to objects on an incline, this angle also then equals theta. Now, the length of the trolley is 97 centimeters, so, and that's from the pivot point to the point where the handle is, and we know that the force on the handle is vertically upwards, which is measured on the Newton meter of 50 newtons. Again, 50 newtons is not perpendicular to the 97 centimeters from the pivot, so the distance and the force are not 90 degrees. We find a component of the force which is 90 degrees to this distance, and that angle ends up as theta, same as the angle of tilt, and that ends up as 50 cos theta as a component, a perpendicular component to the distance. Now, one of the difficulties students face is finding this angle here, and what you need to do is work on a little bit more how you find these angles here. This angle is a tilt, so this entire object is tilted downwards by theta, so therefore the angle of tilt here relative to the vertical will also equal exactly the same. Now, what we are trying to find is the distance of the center of gravity. Determine the distance of the center of gravity, so the C of G, so this distance here. Okay, so what we've got is this object is in equilibrium. Okay, so it's not moving, and that means that the sum of the clockwise moments equal the sum of the anti-clockwise moments. So we can do a moments calculation here, and we know that there's a pivot point here, a force from the pivot and the distance, so that'll be 18.5 g cos theta multiplied by the distance x that we are looking for. That creates a clockwise moment. And the anti-clockwise moment, it is the force, which is 50 cos theta multiplied by 0.97. That's the anti-clockwise moment. 50 cos theta is the force times by the distance of 0.97. Rearranging to find x, what we'll see is that the cos thetas cancel. So we actually do not need to know the angle. And rearranging for x gives us 0.27 meters. Now, it is really important that when we are setting up this question, we set it up as the clockwise, sum of the clockwise moments equal the sum of the anti-clockwise moments. If you didn't include cos theta in your answer, the examiner has set this question up in such a way that if you forgot to include cos theta or you didn't include cos theta, you would end up with the same answer. But there was 1 mark lost if you didn't get the perpendicular components respectively.